Hey everybody, welcome to another episode of Mushroom Wonderland. And a lot of people email me asking about microscopy videos, about fungal microscopy, something that I've been interested in my whole life, but it always seemed kind of intimidating and out of reach, but I can assure you it's not. And although I'm not the best microscopist, today I've cornered Alan Rockefeller. He's kind of an expert on mushrooms and really good at microscopy. You run like the fungal microscopy page on Facebook, is that right? Yeah. So super useful there to get some tips. But on this video, we're going to be looking at some fresh mushrooms that were just picked. And we're going to look at some spores. We're going to look at cystidia. We're going to look at a gill in the microscope and just kind of learn how to make like a basic section, how to take a spore print, how to look at the spores, and how to know what we're looking at in the shot, right? So awesome. Well, thanks for joining me, Alan. And let's get to it, learning all about microscopy on this episode of Mushroom Wonderland. Yesterday we went out and we found some mushrooms out in the wild. And so today we're going to be, what are we going to do first? How are we going to get started?
I think the first thing we should do is look at the spores.
Okay. And how do we do that?
So we got some spore prints here. So we will take some spores, throw them on a slide, mount them, and just take a look at them, because the spores are probably the most diagnostic thing. There's a lot of different things we can look at, but spores are usually the first thing people look at.
Cool. All right, let's have a look at the spores.
So here's our mushrooms. What we did is we left these caps on some tin foil overnight, and we got a spore print. It's not a super dark spore print, but as long as you can see the print, there will be many thousands of spores, plenty to look at under the microscope. So here we got microscope slides. And I'm just going to throw a slide down here. And I got a scalpel. So the first thing I like to do is just wipe the scalpel off in case there's some spores on there from some other mushroom. And then I'm going to carefully scrape up some spores. And we can see just a little bit of these dark purple brown spores on the scalpel, so that means we have way more than enough. And I'll take them, throw them on the slide. And that worked. You can see the powder right there. So since these spores are dry, we're going to put a drop of potassium hydroxide on here. That helps rehydrate the spores. And we don't really want a lot of liquid, so I'm kind of going to go for about a half drop. I'm going to take a cover slip and throw it down on the slide. And the way I do this is I put it on an angle, and so I grab it right here with my thumb and my index finger and slowly lower it down. And I'm trying to make sure there's no air bubbles in there. So if there are air bubbles, I can just raise it back up and lower it down. And make sure there's no air bubbles, especially near the spores there. That looks pretty good. And then we want to press down on this cover slip. So that'll force all the spores into the same focal plane, and that way the cover slip's not just like floating in that drop of KOH, but is kind of adhered to the slide. If you press too hard, you'll notice broken spores all over the place, so you press firmly, but not very hard. And that should be good. I think it's ready to go in.
What if you get liquid on top of that while you're like going to dab it off?
If I got liquid on top of this, I'd probably want to just try to clean it off with a paper towel. And we could paint some fingernail polish to seal this in if we wanted to. So it looks like a real good slide.
I think we should. That'd be kind of cool to have it.
It's kind of cool. So if we paint fingernail polish around the edge of the cover slip here, it's going to seal the water in there. And that way we won't have any evaporation causing currents to flow under the cover slip. So if you ever see the spores just like flying across the field of view, that's caused by evaporation. So press down on this kind of firm just to get all the water out of there. Yeah, it's really always a good idea to use the fingernail polish. It just makes it so you can't wash the slides and reuse them. They're not too expensive though. You don't really have to let this fingernail polish dry. You just don't want to get it on the end of the objective. So I'll throw this slide on here, and we'll start out with a lower power objective. This is the 10 times objective, and then these are 10 times eyepieces, so this is magnifying 100 times. So starting out with a low magnification makes it easier to find what we're looking for, and you can see if you look carefully in this little cone of light here, you can see the spores, so you can just kind of like find the spot that has a whole bunch of them before you even look through the scope. So when you're on a low power objective, you want to close the aperture. So I'm going to slide that. This is the condenser aperture. It's all the way closed to the right, all the way open to the left. So since we're on pretty low power, I'll slide it all the way over to the right. And then you focus, and this looks pretty good here. And so I'm just going to kind of pan around until I see a good spot on the slide. And a good spot has a lot of spores, but not a whole ton. So I want the spores to be pretty close to each other, but not touching. And so I found what looks like a pretty good spot here. And then we can go to the higher power objectives. On this scope, the next one is 20 times. And as you raise the power of the objective, you start opening up the aperture. Next one is 40. So this is magnifying the spores 400 times. Starting to see some good detail here. But when I'm looking at spores, I always look at the highest magnification. So we'll go up to 1,000 times with the 100 power objective. And so this highest power objective uses immersion oil. So this is some immersion oil. And that goes right on top of the cover slip. And you don't need very much. So you just put like half a drop of immersion oil right on top of the cover slip. And what I have to be careful about now is that I don't go back to the 40, because the 100 is an oil objective. It says oil on the side, but the 40 objective is not an oil objective. And so if you get oil on the 40, it'll get really blurry until you clean it well. So you just have to be really careful not to put the 40 in. Go right to 100. And then focus here. And now we'll open up the aperture. So when you're on the 100 objective, you want the aperture either all the way open or very nearly open. And a lot of times I'll just kind of open and close the aperture until it looks best. And now I can see the spores pretty well. And so these spores have a pretty thick spore wall that you can see on the edge. And then they have a germ pore, and that's where the spores germinate from. And then on the opposite side of the germ pore, you can see a little bump, and that's called the hilar appendage. And the hilar appendage is where the spores connect to the sterigmata, which is part of the basidia where the spores grow. And so this is a pretty good part of the slide here, just because there's a bunch of spores, they're all laying flat, none of them are broken, and so this would be a good time to take a picture. And there's lots of ways to take a picture. Often what I will do is just have this camera mounted up top, and I have a remote shutter release here, and so I can just press this button to take a picture. But you can also take a picture with a cell phone. And so when I take a picture with a cell phone, one thing about these kind of phones with a whole bunch of different lenses is it'll usually try to switch from one lens to the next right when you get focused in here, which is really annoying. So if we go over into the Pro mode, we can tell it which lens to use. And that's something that Samsungs can do. I'll just tell it, use the telephoto lens. That way it's just locked into one of these lenses and it won't try to switch it around randomly as we're trying to take a picture. And then this has to be, well, another thing about this is that if you change the focus, like these cell phone cameras are always trying to autofocus. If the autofocus changes, it changes the size. So if you're trying to measure spores, you would want it in manual focus. So here is focus manual. If you're just taking a picture and you don't care about the size, it doesn't really matter. But when you get this camera up here, the camera has to be centered right in the middle here. And it has to be at the right angle and the right distance from the eyepiece. So what I do is I put my fingers right on the objective here, and then I can lay the phone on my fingers. And what I do is just hold the camera up, and I see this dot, the dot of light right in the middle. And as I move the camera closer, the dot gets bigger and bigger until the dot fills the screen, and then I can see clearly through the microscope. So I got my fingers on the eyepiece here, and you see that dot of light, and I just want to keep that dot in the center of my screen as I move the phone closer and closer. And then you can see the spores really clearly. Shoot! And there I just took a spore picture. If you look at it, you can see that it's nice and clear. So here's the germ pore here. Here's that thick spore wall. So some mushrooms have germ pores, some don't, but things like psilocybe, Sarsaparilla, Foliota, they will have germ pores.
Can you point out a good one? Where is that?
Let's see. So I think this one's nice because we kind of, you can see both sides. So on this spore here, we have the germ pore here. So the spore wall goes all the way around, but then the spore wall stops. And so when the spore germinates, the mycelium is going to come out of that pore and start growing across this way. And then opposite of the germ pore, you have the hilar appendage. It's also called an apiculus. And this is just a little knob there, the little bump, and that's where the spore attaches to the stigmata. So the spore grows from this point here. So I'm going to look for some chylocystidia, which are cystidia on the gill edge. So I'm going to take a fresh mushroom here and just use these fine tweezers and try to just grab one gill. And sometimes they kind of rip, it's kind of hard to tell if we got a good one, so I'll just keep doing this until I can see it's working really well. I think that worked, but I'm not totally convinced. Okay, yeah, I can see exactly what happened here. So I just grabbed this gill, so the chylocystidia will be on the top part of what I grabbed here. So I'm going to take that, put this down on the slide. So right now, the chylocystidia are going to be facing me. I'll take it off with a scalpel. And this is probably the part where it would help to have a dissection scope. See, I don't know if I'm seeing any. Oh, okay, cool. So the gill edge is this edge right along here. So that means the chylocystidia will be along this edge here, and then pleurocystidia will be all over here. So since we already found some pleurocystidia, we just want the very gill edge. And so I'm just going to try to cut the smallest piece of gill I possibly can, where we're just getting only the edge. So if I just cut right there, that's pretty thin. You can see we left 90% of it behind. And just have this little strip that was the very edge of the gill. And then let's take this part that has the pleurocystidia and we'll throw that away and mount this. A half drop of water on there. Slowly put down the cover slip. Oh nice, there's no air bubble, that's great. Yeah, that looks really good. So I'll throw this on here, see what it looks like. Okay, so here is our gill edge. And it looks like one side has a row of chylocystidea, and the other side is where we cut it with the razor blade. So we're just going to kind of, well, we'll do a crush mount first. I'll zoom in just to show you what the gill edge looks like. So here is 200 times magnification. Here's 400 times. We'll open up the condenser diaphragm a little bit. And now you can see all of these bottle-shaped cells here. And they have kind of thin, long necks. Some of them are kind of crooked, going off in other directions. Other of them are kind of regular. But you can see that there's just a ton of them. And so when you look at the edge of a gill, often you'll see a white line right down the edge of the gill. And it's this row of cystidia that is causing the edge of the gill to be white. Also, you don't see any basidium. You don't see any basidia, you don't see any basidioles on the edge of the gill here, so that's what's called a sterile gill edge. And since the gill edge is sterile, there's no spores growing there, so the gill edge is white. So what I want to do is do a crush mount and just crush. I'll just pick a random spot on the gill and we'll flip back to our 100 times magnification. And we'll try crushing this gill edge, see if I can break some of these chylocystidea free so we can see the whole thing. And there's the scalpel there. That looks pretty crushed. I think that was pretty successful. Let's see, where's the best place to zoom in? Probably around here. So back to 400 times. And here we have some chylocystidea that's broken free. So when you see something like this, now you can measure the whole cell because you can see the cell has been broken free from the gill edge. And I like little pieces like this because you have a whole bunch of them that are still kind of connected to the terminal cells of the lamellar trema, and they kind of stick together, so it's kind of like a whole rosette of chylocystidea. These longer cells here are the lamellar trema cells, so those are the cells that make up the structure, the inside of the gill. And as you go back into here, you can, it looks a lot more jumbled, you kind of got a lot of stuff on top of each other. So when you're doing this, you make this debris field when you do the crushing, and then you kind of look into the edge of the debris field, and that's where you see all of the cells that are broken apart enough, far enough away from the rest of them that you can actually see what's going on. And a lot of times what I will do is find a little cluster of them that I really like, and then we'll zoom in to the highest magnification, so that'll be with the 100 times objective, we'll magnify it 1,000 times. I'm going to throw a little bit of immersion oil on here. And that'll Let's see if we can find, there it is right there. And so here, as I adjust the fine focus, the chylosestidia comes into focus here. So this is the very top of it right here. You can see one of them is coming into focus, and then a whole bunch of other ones are coming into focus as I go down, as I focus downwards. But at no point are all of them in focus at once, because this sample is a lot thicker than the depth of field when you're magnifying 1,000 times. So what I'll do is take a whole bunch of photos and use a technique called focus stacking to combine all of those into one image where everything is in focus at once. So what I'll do is focus up to the very top, where you just go down until the very first thing comes into focus, and then I'll take a whole series of pictures. So I'll take a picture there, and I'll focus down a little bit, take another picture, and I'll just keep doing this until I get all the way to the bottom, or just until I get the parts that I want in focus. And then once I have all these pictures, I can load them into Helicon Focus, or Zerine Stacker, or Photoshop. And I think that's all, it was all of them there, that was the bottom of it. And then we can combine all those and we'll have a really nice chylosestidia shot. So next we're going to look at some gills, and there are three important things that we might see on the gills: the chylosestidia, the pleurocystidia, and basidia. So chylosestidia are cystidia on the gill edges, pleurocystidia are cystidia on the gill faces, and basidia are all over the gill faces, and those are the cells that grow the spores. So the cystidia will be little bottle-shaped cells, and so the first thing that we have to do is just grab a gill. We're going to get a microscope slide ready here. So here we have our mushroom, and if you look closely at these gills, you can see that there's a white edge on the gills, and that white edge is the chylosestidia. And so I'm just going to move this here. Yeah, you can see the white edge pretty good here, so it's a row of chylosestidia right along the gill edge. And then the pleurocystidia will be down there, so any cystidia that are not along the gill edge will be pleurocystidia. So I'm just going to go in and grab one of these gills. This one looks good. Try to bring that out of there. And there we go. So now if I turn this here, the side that's facing away from me was the gill edge, and that'll have the chylosestidia. So if I can, and that looks like it's, you know, this little piece I got, it's kind of like the flat edge. And often if you just kind of like turn the tweezers here, you can get it to drop the gill. Just flipped it over. There we go.
And you still know which edge is which.
Flat. So if I remember correctly, the chylosestidia edge, the very edge of the gill, or the part of the mushroom gill that would have been facing the ground as it was growing, is the part that's closest to me. So I'm just going to take a razor blade and cut this. So when we're making a microscope slide, the most important thing is that we use an extremely tiny bit of material. The general rule is if you can see it, you're using too much. And the reason for that is that if we have a lot of material, then it pushes up in the cover slip and the sample won't lay flat, And also, if you have a lot of material, then you just have piles of cells and you won't be able to actually see what's going on. So I'm just going to try to cut the very edge of the gill off of here. And that did work. There I have just a little bit of the edge there, and it stuck to the razor blade, so I'm going to try to go like this, see if I can get it to drop the gill edge, and that worked. So here we have just the very edge of the gill here. I can just barely see it here, and then here's the rest of it here. This is a fresh mushroom. Doesn't really matter if we use water or potassium hydroxide, but potassium hydroxide is what I have. So I'm going to put just a half drop of potassium hydroxide down here. Grab a cover slip. Now if we hold these cover slips up to the light, we can see that they're extremely clean and clear. So that's what happens if you buy high quality cover slips. If you buy the really cheap cover slips, you hold them up to the light and they're kind of frosted. Sometimes you can clean them and sometimes the glass is pitted and you can't. But these, I got these from, I think it was Thor Labs. And so these are the high precision cover slips, and they're a little expensive. They're like 35, 40 bucks for a box of cover slips, but it's really nice not to have to clean all of them. So I will throw this cover slip on here. You can see the way I'm holding it. I can just raise and lower it with my finger here because it's kind of diagonal. I'll slowly lower it down. We're lucky we won't get any air bubbles. And the drop I used was really small, so it hasn't even really expanded over, but I'm just going to try pushing down on the cover slip with this paper towel so I don't leave a fingerprint, and we'll see if we even have enough liquid to do this mount or if I have to add more. Okay, I got it, just barely, but this looks like a really good mount. There is no visible air bubbles in here. And then we have both pieces of our gill. We got our bigger piece down here, got a smaller piece up there. So we can put fingernail polish around this, or we can just leave it off. We can give it a try without it maybe this time, and see what these cells on the gills look like. So we're going to throw this slide on here now. I've gone back to the 100 times magnification with the 10 times objective. Close the condenser aperture, throw this in here. And before I look through the scope, I like to just pan around. I can see the gill edge light up in the light here, then I know that I'm kind of in the right ballpark. Alright, so this is coming into focus now. See the gill edge pretty well. So I'll just find kind of an interesting part to zoom in on. And it looks like this little piece over here looks pretty cool. I see some basidia coming out there. So here we have 200 times. I'll open the condenser diaphragm a little bit and go to the 40 objective. That'll give us 400 times. Refocus over here. And open the condenser diaphragm a little more. Now if I open it too much, it looks a little bit washed out. So here I have a basidia, a whole bunch of basidia. And so the plural is basidia. Those are the cells where the spores are growing. And then we also have some basidioles surrounding them, and those are immature basidium. So these basidia here look like 4-spored basidia. You kind of focus up at the top, that first sterigmata comes into view, and then focus down and see the other. But I think I do see a two-spored basidium too. So usually the basidia have 4 sterigmata, and then the spores grow off of the sterigmata, which are those little things that look like horns. But occasionally you'll just have 2 sterigmata instead of 4, and then it really looks like devil horns. And when you have 2 sterigmata, then the spores get a little bit bigger, because each spore kind of gets a little more energy. So I'll pan around a little more, see if we can see anything else on here. Oh, I see a bottle-shaped cell. And so this kind of looks like the top of a wine bottle. And I just see one, I don't see a whole row of them. And I don't see any gill edge around here. So this is a pleurocystidia. The pleurocystidia are on the gill faces. So when we're seeing these cystidia, we can only see the top half of the cell poke out, because the bottom half is embedded in the gill. So what we can do is a crush mount. So what we'll do is we'll press down on the cover slip, and that will crush all of the cells, break all the cells free, and then we'll be able to see all of the cells free of the gill. We can see the whole cell.
Does that damage the cells? I mean, do they look different by doing that?
It shouldn't, but if you press too hard, it will. So if you see broken spores, you press too hard. And here I see a basidium, and it has 4 spores coming off of it. So you can see the mature spores growing directly on the sterigmata here. Before I do that, I just want to zoom out and take a look at our other piece of gill. Let's see what we have going on over here. And we got a big air bubble coming in, and that always happens if you don't paint fingernail polish around. See, there's the air bubble coming in here. So you definitely have a limited amount of time to work with these things. A lot more if you paint fingernail polish.
Does it ruin the slide with fingernail polish?
I mean, I suppose you could take a razor blade and take it off with a razor blade, but generally, yeah.
You want to make sure you're doing a pretty good job up to when you're going to paint it, or just start over or whatever. Like, there's no going back once you paint, basically.
I think so. Let's try a crush mount here. A lot of things you can use for a crush mount, like a pen or something plastic is good so you don't break the slide. But what I have here is just the scalpel, and I'm going to give that a try. And what I like to do is do my crushing while I'm looking through using the 10 times objective. That way I can see exactly what I'm crushing, and I can see how much I've crushed. So if I just put the scalpel down here, there's the scalpel, and I can just start to press down here, and you can see it's starting to break some cells apart, and that's not really crushed enough. Let's try to do it a little bit more. I don't see any broken spores yet, so we haven't pushed too hard yet. You can see it's starting to break this tissue apart. And let's do a tiny bit more. Oh yeah, it looks like it's working pretty well. So now if I flip back to the 40 objective, we have here kind of a debris field, and we have all these cells floating free. So like right here in the middle, here's a basidium. And we see a bunch of basidioles around. Here's a 2-spored basidium right here. And so if you wanted to measure the whole basidium, you could do that because you can see the whole cell just floating free here. Now up over here, we have some pleurocystidia. So you can see the pleurocystidia. It's kind of bottle shaped, and then down at the bottom of it, that's where it was embedded into the gill. So most of what we're seeing here are basidioles and basidia. There's a pleurocystidia right there. And then over on this side we can see just a couple broken spores. So you can see also, not only did the spores break, but some of the other cells broken too. You just kind of get some debris, some broken basidium and basidioles over in there. There's some nice pleurocystidia there. And then here's a little piece of cell where it looks kind of cool because it's kind of round. They're kind of coming off in all directions. You have a bunch of pleurocystidia, basidium, and basidioles. So inside of the spores, you have the nucleus, which is where all the DNA is stored, but you can't see that without a special stain. But one thing you can see on the inside of the spores are these little oil droplets. And so these oil droplets are food for the germinating spore. Let's see if we can find some clamp connections. So here we have a nice bottle-shaped chylocystia, and then the chylocystia is attached to the subhymenium, which goes down into the lamellar trema. But right where the chylocystia attaches to the subhymenium, at the base of the chylocystia, you see this other kind of like little knob coming off with a cell wall or a septum, and that is a clamp connection. So this chylocystia has a clamp connection at the base.
So an ID feature on a lot of mushrooms is with or without clamp connections. Can you kind of explain what the clamp function is and why it might not be there?
Yeah, so clamp connections, when you have two fungal cells, you have a septum, which is like this dividing line between one cell and the other. And when you need to exchange nuclei or have a nucleus move from one cell to the next, then the clamp connection is what allows that nucleus to pass. So the clamp connection is a little bridge that bridges the septum, and then it can allow the nuclei to pass, but if there's like a bacteria or a virus or something like that, it won't allow that to pass. So it's like a little valve or a little gateway that just allows nuclei to pass.
Cool. So when a fungus doesn't have clamp connections, what's going on there? There's no passage of nuclei.
So if you do see clamp connections, you know it's a basidiomycete fungus, and it's diploid, which means that it's mated, and you can have both of the nuclei in there. Now, if you don't have clamp connections, it's either a basidiomycete that doesn't have clamp connections, or it's something else, like an ascomycete, like a mold.
But a basidiomycete that doesn't have clamp connections, how does it pass its nuclei?
I don't know.
Oh, okay.
It figures it out.
Crazy. Okay. And is it more common to see clamps or without, or is it just
No, usually you'll see clamps, but if you see, if you read the key to the genus Foliota, the first thing it asks you is if there's clamp connections. And then if there are, then you go to this one part of the key, and if there aren't, you go to this other part of the key. So, sometimes it's like a real diagnostic thing.
Sometimes literature will say clamp connections absent.
Yeah.
And I'm like, I don't know if I'm not seeing it or if it's not there, and I guess that will come with experience.
Yeah, and that's, one kind of difficult thing sometimes, because, sometimes it can take a while to find clamp connections. So it's like, well, how long do I look for clamp connections before I call them absent?
Exactly.
You can look for 1 minute, 5 minutes, 15 minutes.
Exactly. Yeah, I've wondered that. I'm like,
yeah.
Because I've looked around and I'm like, I bet you they're here. I'm just probably not looking in the right place.
Yeah, I think usually 10 minutes or so is kind of reasonable.
So the clamp connection, not only between two just hyphal cells, but also connecting some of these more specialized structure.
Yeah, whenever you have a septum, you can have clamps.
And so are the septum permeable? Can things pass through that septum, or it's like a hard...
Kind of semi-permeable.
How does fluid flow through the mycelium? Wouldn't it get blocked at each septum?
Or at least slowed down, yeah.
How many of these spores do you think it will take put together before the human eye could see it?
That's a really good question. If you stack 100 spores from, just like line them up, that would be 1 millimeter. But, that would be such a thin line, so, I would say maybe 1,000 or so.
And we might see a little speck of black.
The tiniest speck,
Yeah, wow. Yeah, so one of those spore prints, a heavy spore print, we're talking about millions and millions of spores. Right?
Oh, yeah.
And all you need is 2 of them to germinate and mate, right? That to start a new fungal colony.
Yeah, just 2 of these spores. If we wanted to see more features, the next most important feature is the pileapellis. And so that is the very top of the cap, and we look at a cross-section of that to see how the top of the cap is arranged. And then we could also look at how the lamellar trama is arranged. And for both of those features, it really helps to have very dry material. So if I have like fresh mushrooms, I'll dry just like a little bit before I slice them, because you need something to be really dry in order to slice it thin enough to see these features. So we're going to try to take a look at the pileapellis, which is the very top of the cap. And so what I'm going to do is take this brand new razor blade and slice some very, very thin sections. I'm just going to cut one like that, and now I'm going to try to cut some more that are parallel to that, but extremely thin. Just barely shave a little bit. And see that thin piece right there? Actually looks pretty good. That might do it.
Is that called a tangential section?
No, it's a scalp section.
Okay.
So like this little piece here, that's pretty promising. I'm going to throw that on a slide. It helps to make a few of these. That way you have more chances for success. Because some of them you won't see too much, and others will look awesome. So a lot of times what I will do, get it focused pretty good here. So a lot of times what I'll do is like kind of cut it on a little bit of an angle, where one side is way too thick and then the other side is just like trailing off into nothing, and that side that's like impossibly thin is trailing off into nothing. That'll be the really good parts where you can really see what's going on. And it really helps to have a brand new razor blade for this. A lot of people will say like after you make like 10 cuts or so, you retire the razor blade, use it for something else, because once the razor blade's been used a little bit, it can't cut as thin as you need it to. Let's try to make a few of them here.
Do you usually use the dissection scope?
Yeah, for this, the dissection scope really helps. For Chilocystidia and Pleurocystidia, you don't really need the dissection scope, but for these kind of things, yeah, you kind of do need the dissection scope. So, we've got a few pieces here. One of those will probably work. So I'll have that over on one side of the slide. And then on the other side of the slide, we'll cut up a gill and see if we can see the lamellar trama, which is the inside of the gill. So, this mushroom is a Gallorina marginata, a deadly Gallorina. And first thing I'm going to do is just try to grab one of these gills, the biggest one there. And this mushroom just came off of the dehydrator, so it is super dry. Let's see, did that work? No, it's just some garbage there. Okay, so here we have one gill. So I'm going to take that one gill and focus back down on the slide. Okay, so there's one gill. And now I'm going to try to hold it down so it doesn't move, and then I'm going to make a whole lot of parallel cuts. I'm just trying to make them as close together as I possibly can. So making a whole bunch of these gives us a bunch of different chances for success. But the one that's going to work is just going to be really, really tiny. So like this one here, way too big, but this one over here, that looks pretty promising. So maybe I can take some of these that are way too big and just get them out of here. That way we don't have too much material. And we'll just have these really, really thin pieces. Cut this. Let's make it smaller. And since this is dry material, we'll definitely want to mount it in calcium hydroxide. Just put a drop of KOH right there. And then here's our Pileopellis pieces. Drop a KOH right there. One thing that really helps is if you can mix these pieces in to the KOH and then let them sit in the KOH for a couple minutes. They'll absorb water. Because if they haven't absorbed the KOH and the water into the cells, then there'll be all sorts of air bubbles around the edges. But if we could mix this together and just let it sit for a while, then there'll be a whole lot less air bubbles when we go to add the cover slip. Even letting it sit for a minute is pretty helpful, but some people let it sit for like 5 or 10 minutes or even longer. So that was our Pileopellis pieces. Here is our little cuts of the gills. Try to see the lamellar trema in there. Just try to mix it up so they're all submerged in there. And here's the cover slip. Put it down. See some air bubbles, but let's see, I'll just push down with a paper towel and try to have it so the air bubbles move off to the side. That looks reasonable. And then we'll grab another cover slip. And this is for the Pileopellis pieces. And on this one, we just don't have enough material, so no matter how much I push, we still only have liquid on one half of the slide. So what I can do is just add another drop of KOH right on the edge of the cover slip, and it'll flow under the slide there, and just kind of fill it up. And that I had to do that is kind of indication that I have too much material or too thick of a slide, but you know, some of it might work. I see an air bubble in there, so I'm lifting this up, setting it back down. And press down to try to force everything into the same focal plane so it's nice and flat. Press down on this side a little bit. It feels like, actually I can feel a grain of sand under there, so I think there was a grain of sand stuck to the cap. And that's kind of causing the cover slip not to sit quite flat. Sometimes you can just kind of crush the piece of sand and it'll break. Oh yeah, that's exactly what happened. I felt the little piece of sand breaking and now the cover slip's sitting flat. Let's throw this on, see what we can see in there. There's our cuts. And so this looks pretty good. So over here we can see the gills, and so you can see all the spores growing on the gills here. And then if we look towards the middle of the cap, this is the pilus trema, so that's just the very inside of the cap. And then up here, this darker part, this is the pileapellus. So that is the very top of the cap. And if we go kind of over to the middle here, it's thicker and harder to see what's going on, but here it gets thinner and thinner. And so if we look right around here, we'll be able to see the structure of the pileapellus the best. So we'll zoom in, we'll take a look at 400 times magnification. And that is it right there. So this pileapellus looks like it's kind of made from a whole bunch of interwoven hyphae. Kind of looking in here, there's the pilus trema, so the very middle of the cap. Got a few air bubbles in here. We could have gotten rid of those just by letting it soak for quite a while. Back at the pileapellus. And then if you don't make a spore print, you can find mature spores by looking on the pileapellus, because then a lot of times mature spores will sit on the top of the cap. So right in the middle there we have the lamellar trema. On one side of it we have an air bubble, and the opposite side of it we have the subhymenium, and that's where the cells of the lamellar trema get real thin, a lot smaller, and then all of these basidia and pleurocystidia arise from the subhymenium. And I'm just going to put some oil in here and go to 100 just so we can see these spores, because these spores are a little bit different. So here's the 40, I don't want to get oil on the 40, here's the 100, so we're right between the 40 and 100, just put the oil right on the top of the cover slip and then slide the 100 objective into place. This spore is Gallerina marginata, and you can see that the Gallerina spores are not smooth, so they are slightly ornamented, verrucose. So you can see that texture. This is the very top of the spore, and then if we focus to the middle of the spore, you can see that texture on the edges. Another thing you notice about Gallerina spores is that they have no germ pore. So they do have a bump at one end, the hilar appendage, but there's no germ pore, no break in the spore wall for the spores to germinate from.
Where do they germinate from then?
Opposite the hilar appendage, but it just comes right out without needing a pore.
It just breaks through the wall.
Yeah.
All right, Alan, thank you for the microscopy video. Really helpful. This video is kind of assuming that you already have a microscope. We didn't talk too much about the microscope itself and its particular parts. Perhaps that's for another video. If that sounds like a good video, please put that in the comments. But if you're looking for a microscope, do you have any kind of suggestions for something to get somebody started down the road of microscopy?
So the least expensive microscope that works really well for mycology is an M-Scope B120. So that one costs about $250 new. And then if you want something a little bit more expensive with better optical quality, Motic has quite a few microscopes, and you can pick one up for maybe $300 to $600. maybe 1,000 for the ones with the really nice objectives, and those work just as well as something like an Amscope, except that they give you a nice sharp image. So you'll be able to look through it all day, not strain your eyes, take really nice pictures, that sort of thing. But if you just want to do work with mycology, something like an Amscope will work just fine.
If you're reading your identification books, oftentimes it refers to microscopy, so at least we got to take a look at what some of these fungal structures are, what they mean. So I really appreciate it, and we look forward to maybe making a more advanced microscopy video in the future. Put that in the comments if that sounds good, and in the meanwhile, we'll see you somewhere down the mushroom trail. So much love, everyone. Peace out. Gunner, that's enough.
I know, I can totally do it. I hear that.
I got it.
People are going to think it's boring.